Okay, so we just by basically assuming that the events are ticks of a clock that are at rest with respect to the S frame, we've been able to show that alpha 1 in this general transformation is equal to gamma, and that alpha 3 is equal to minus gamma beta. Okay, now we can use the invariant interval, which I've written, shown here. C times delta t prime squared minus delta x prime squared is equal to the same quantities in the unprimed frame. Now we can use that invariant interval to find the other two, alpha 2 and alpha 4, the other two quantities. So if we plug in for C delta t prime this expression, and the fact that alpha 1 now we know is equal to gamma, and for delta x prime this expression where we know where alpha 3 is equal to minus gamma beta, then we get the following expression. Okay, here it is. Here again, this is the expression for C delta t prime using this and the fact that we know alpha 1 is equal to gamma, and here's the expression for delta x prime. Okay, so again, when you do that, when you carry out these squares, these squared quantities, when you square the terms in brackets here, you're going to get terms that are proportional to c delta t squared. Okay, which on the right hand side we have over here. Okay, it comes from this side. If we're also going to have terms that are proportional to delta x squared. Okay, and then we're going to also have cross terms that are proportional to delta t delta x. Now, since there are no delta t delta x terms on the right hand side, we know that the coefficient that those terms have to be equal to 0 identically, and we know that the c delta t squared terms have to be equal to 1. The coefficients have to be equal to 1, and the coefficients for the delta x squared terms, the coefficient has to be equal to minus 1. Okay, so I'm not going to go through all the math, but if you group terms and then set them equal to the appropriate thing from the right and left hand side, then you'll get the following. Okay, so if you expand these and then group the terms that are proportional to delta x squared, you get delta x squared. From the left hand side, you get delta x squared times alpha 2 squared minus alpha 4 squared is equal to minus delta x squared on the right hand side, and so we get that delta 4 squared minus delta 2 squared is equal to 1. Okay, now if we group the terms proportion to c delta t squared, that equation doesn't involve either alpha 2 or alpha 4, so it's not useful to us. But if we group the terms that are the cross terms that are proportional to c delta t times delta x, then we get this expression. Okay, and there's no cross term again on the right hand side of the equation, and so this is equal to 0, and so basically what's inside the brackets here is equal to 0. Okay, so this gives our second equation. So now we have two equations, A and B, and basically what we want to do is solve A and B for alpha 2 and alpha 4. Okay, and if you do that, what you find is that you get, I'm not going to do it for you, but what you find is that alpha 4 is equal to gamma, the Lorentz factor, and alpha 2 is equal to minus gamma beta. Okay, so finally we have our Lorentz transform equation. So what we have is that CT prime is equal to gamma times CT minus gamma times beta times x. Okay, and x prime is equal to minus gamma times beta times CT plus gamma times x, and then also y prime is equal to y and z prime is equal to z. So these are the Lorentz transform equations, which allow us to go from one coordinate system to another.